All right. Hopefully this thing's working. Danny, this is a message to future you. Um, this is just to hold you accountable and actually making this project and not giving up on it. Um, and like, what is this project? Uh, oh, I want to make the an ECU for the RX-7, but I don't know too much about it, especially since I think I'm gonna have to learn a lot to actually make one for a car to put onto the road. So I'm gonna start by making just a motor controller, but then also put it onto a little RC car. And then you might be trying to do the same thing as Jorge over the summer. So it's just to hold myself accountable, and then I can like talk things out and have like a record of it. So yeah, what are the stuff that I'm gonna want to do? I want an RC car that has all-wheel drive because I want to be able to send power to each wheel individually, and then I'm gonna figure out some way to control it. Either I'm thinking of like an Xbox controller through like some type of program that I have on my computer, and then you can just wirelessly talk that way, or maybe actually do two ESPs. Oh yeah, also Danny, you're gonna be using an ESP to actually be controlling everything, and um, yeah, you're gonna be using ESP to control everything. Might switch it up. Yeah, I know I want to use a Zybo or some other type of thing, but I think I'm gonna go with the ESP since I know I have one. And then I realistically I want to do that STM, but because of the documentation for it, but I'm gonna go with the ESP, and I'm gonna try to go as bare metal as possible. Of I'm gonna be using their API that they have now, but I want to soon go and actually read through the manual and get every what's it called actually hit registers to be able to do things. There's also some things that I want to do of I want to there's some peripherals I want to use that I want to make sure hit the like land on there. Maybe I throw oh actually I want to throw can in there too. And so this is just a way to document it. But yeah, so the car will have all-wheel drive. I want to do some type of control theory of having some PID loops in there so that I can get adaptive feedback for the or like adaptive throttling for the wheels, and then kind of have some type of traction control. And I want to be able to zoom or view the camera feed and then control the remote control the car that way because I feel like that'd be cool to do. And also, I want this car to be somewhat fast, so but I also am gonna restrain myself to $300 because I don't want to spend more than that. And I guess this is like the first thing I'm doing today. Today I just want to just I was setting it up. I do want to get the debugger working, but I don't know how to do that yet. So I'm just gonna be setting up, going through this, and then I kind of just want to start doing stuff with the ESP board. So today I'm gonna try to. I won't consider it a successful day until I can read a potentiometer and change PWM on a pin. And the way I'm reading it is but to know what I'm actually doing is I have a little like pocket oscilloscope to actually be able to view the like PWM signals or analog signals and the digital or analog signals coming off of it. So let's get started. So I want to use the ADC on there to actually read the potentiometer. So first let me just make sure I am in here. So oh yeah, because I will use Copilot, Danny. I know you don't want to use it a lot, but like for some things I don't know exactly what I'm doing, and so I will use Chat GPT. But I'm also gonna try to do everything as I guess manual as possible. So let's see, what's the first thing I'm gonna do? Uh, to print start up message, just so I know like I'm making incremental steps. Print telemetry messages, read ADC, and get the data value. Also, I'm wanting to stream it because I want to actually be able to talk out loud, so I can get better at that. Get the data, and then once I get the data, I'm going to map it 0 to like 100% or something like that. Percent. Um, and then let's see, output a PWM signal, and then change PWM signal, and then go from pot to PWM pin. There we go. Oh, there is something I will. Let's see. Would it be implement? Because I do know I'm gonna have to do this, otherwise I will get messages from the watchdog timer. Because ESP has um, some. It always runs with FreeRTOS, and so the watchdog timer is always trying to watch out for stuff. So let's include this library. Okay. So let's see. Init code, and then main loop. While one. Let's see. First I'm gonna want to configure pin GPIO 4 as analog input, or do I have to? We'll see. Because I know for the STM board you have to go analog input and then go into the actual ADC stuff, but we'll see. And then after I do this, I'm gonna throw the potentiometer into its own header file. I just want to be working with on main first. So let's see, if I want to use the ADC, right now I'm just gonna go for a one shot because I feel like it's gonna be easy. Let's see, resource allocation, cover parameters need to be set to ADC handle and recycle ADC when finishes. Cover the parameters to set up the ADC unit, because we're gonna want to do that. Read the result, read these things. Also, probably throw it into an ISR just because I want everything to be as interrupt driven as possible. The ADC one-shot mode drivers implemented based off the SAR ADC, especially different chips. I have different one-shot ADCs. The point, an ADC instance is represented by the ADC one-shot unit handle. Okay, to install it, we're gonna have to set up this type of struct, and then selects the ADC. Refer to the datasheet to know which dedicated analog I/O. Okay, and then I've decided to use pin GPIO 4, so I will be using ADC 1, 3. I might end up switching it up and go one analog, set it up for the pin 4, and then maybe set it up for like pin 9 or pin 11, just because I want to be using different ADCs just to see if I can. So yeah, so right now I'm going pin 4, so that should work. Yeah. And then select the source. If set to 0, the gyro will fall back to a default source. I think we're just going to go for default clock sources. I don't want to get into too detail with the clock sources. So I'm not going to be using the ultra low power processor, so I don't think I have to worry about the ULP. After setting up the initial configuration for ADC, call this to prepare it with the config struct, and then I'll return a unit handle. Then if the allocation is successful, so I do gotta check that. just because I do want to try to make this as fault tolerant as possible, I will do a int pot init function, and then int pot underscore init function. I'm also going to try to document it as well as possible. So here, at description, all right, I'm just going to say return. And then pound define pot init fail. Define pot init success. So let's make this a 0. Let's make this a 1. Yeah, okay. Pot init success. Just return pot. We'll have chat write all the documentation because I would rather do that. That's what I like to use it for. So let's see everything that goes into making the handle. So create a unit handle under a normal one-shot mode. Okay, so let's see. I'm gonna want to do pound include driver. Oh, so I'll usually under driver backslash adc.h. Is that what it is? Well, let's keep reading. Okay, so create a handle under that, and then I think I'm going to want to do that, and then delete it after I'm done using it. After the ADC instance is created, set up the channel configuration. This is probably where I'm going to have to do like channel 3, I think it is, for GPIO 4. ADC attenuation. I also don't know too much about attenuation stuff, so I wanted to learn about that. The bit width, okay, and then for the channel, okay, yeah, check that. Additionally, IO to channel and channel to IO can be used in. Okay, I could probably use these and or experiment with those to make sure call the channel. So this is to configure the channel with the struct. Okay. Configure 2 channels. Ooh, maybe I try to go for 2 channels at once and see. Okay, read the result, the conversion result. After above configurations, ADC is ready to measure the analog signal. Call the one-shot read. Okay, so it's safe to use. ADCs are shared some device peripherals. Hardware limitations, probably have to read those. Use mutexes to avoid concurrent hardware usages. Okay. Where the function should not be used in ISR. What if it's like reading within the ISR? Let's see. Because I don't know if I'm going to want some polling or stuff to read. Okay, yeah, and then probably use the ideal function to, or ideal equation to get the V out. Okay, read the raw result, probably check that stuff out. And then RNG uses ADC as an input source. When the ADC works, generated, it will be blast random. Okay, so if I want to use the ADC RNG later, you probably have to look at that. The specific ADC can only work under one operating mode at a time, either continuous mode or one-shot mode. Okay, ADC 2 is also used by Wi-Fi. Okay, so maybe if I don't use ADC 2 if I want to use Wi-Fi stuff. So when the power management is enabled, I'm not going to be doing anything with power. I'm not going to try to make it as low power as possible. Ooh. So IRAM save. All the one-shot driver APIs are not supposed to be run when the cache is disabled. The cache may be disabled due to various reasons. Okay, so these are all safe to use for multi-threading. We'll load that up. Okay, and then, yeah. okay, so that's what I want to. Let's see what functions they use and or what headers they include. So I think I want to do, where's their main? ADC calibration. Because yeah, I know for the STM board you have to do a lot of the configuration for it. Where's their main? At main, okay, call the one shot, error check it, and then do the channel configuration. Yep, and then you have to do calibration, but I didn't see him do anything in documentation. Okay. So yeah, let's see. ADC1 configuration. Okay, so that's all that. Well, one, do calibration. Oh, this, okay. Where are all of these? Okay, so these are on this header file. Okay. So I want that file for ADC header. Let's see what. Okay, so let's see what they say to set up first. To set up under normal one shot. Okay. Here we go. I want to set up this type of handle. Let's also pound define. Pot pin. I'm using GPIO 4, so GPIO num4. Have to do a pound include driver. Why can I not do it? Oh, because I'm in this. Okay, so if I want to have to open one, then how do I open the ESP? Let's see if I open and close VS Code. It should. Yeah. Okay. It should be import a project. ECU. This. No, I think I just made a copy of it. Yeah. Okay. I don't want that. I want to. Okay. What happens if I try to just build this stuff? Yeah, I knew it was gonna throw an error. Okay, yeah, because it doesn't have a CMake. Oh, okay, so then do I just have to open this folder? Yeah, because I want this GitHub. Password include driver. Okay, yeah, driver and then G. Ooh, let's see what's in this. Go to this definition. What's in this ADC? Oh, I am using S2, so yeah, I gotta change the device target. Be the S2 via prog. So get IO. Oh, okay, so I get their channel. Oh, okay. Channel, okay. Other functions for stop the digital ADC and DMA. ADC, this is what I care about, initialize. Read by turn of digital ADC. Okay, because I am going to want to use. So is this what I kind of want to do? Where's the ADC? ADC1 and NIT stuff. Because I do know that there is something for just. That's the one shot driver. Okay, yeah, let's just follow this exactly. So this calls the ESP. No, that's for that. Let's see, ESP one shot. Maybe. Hopefully, I don't need the other one too. Oh, I already have it here. Go to the definition. I'm going to need this struct. Oh, I already have it down here. ADC1 handle. What do I call it? The pi. Okay, so once I have the handle, then I can do the config. Pot config, so CFG is equal to that. Dot clock source, I want to do the ADC underscore clock, RGC clock default, right? It says something about having a default handle, right? Oh, that's the channel config. Where's the init config? So what are the clock sources? The one-shot clock source. ADC one-shot clock source. ADC one-shot. Oh, wait, that's just the data type. I think I was good there then. Let's see where these are defined. Use, okay, yeah, use this as the default. Oh, but they go to the same thing. Okay, and ULP mode, this said no. ADC underscore ULP disable, and then unit ID, this should be ADC underscore unit 1. And I call the ADC underscore one shot. Is it this one shot configure channel? No, it's not configure channel. Oh, new unit. ADC underscore one shot new unit. Yeah, okay, new unit. Let's go see what this wants. Okay, so it wants to return in a handle. Do the address of the pot config, and then pass in the address of the pot handle. Oh, this needs. Okay, so after you do that, what does this return? Yeah. So if equal ESP error. What does this return? Error fail. Okay, so this is ESP fail. Return pot init fail. And then that, I don't think I need to check the error or delete it if it fails. So let's not worry about that. Okay. So once I did that, now I gotta do the ADC one shot channel config. Go pot. Channel. CFG. Dot attenuation. ADC attend. I don't know what the different attenuations do, so we'll check. Let's see, with these attenuations, no input attenuation, it can measure to approximate. Oh, we extending the range. Okay, so I don't think I want any attenuation then. AC attend 0 dB and then dot bit width is equal to ADC bit width. Let's go for 13. Alright, let's go 12 for now. Yeah, because I want to use a 12-bit ADC, and then I'll throw it up to 13 just to see how exact it gets. So define pot ADC bits. So right now I'm going to do 12, but I want to be able to easily change it. Define pot ADC max. Going to be 1, shift it over pot ADC bits minus 1, because that's the max val. And then define pot vref millivolts. I want to be in, I'm using 3300 millivolts for my vref. Okay, so here we go. Print S, because this will print just regularly. Done with initialization. Damn, that's terrible. Initialization. I think so, something like that. Throw a new line in there. I don't think I'm going to be doing anything in this main loop for now. Let's just see it. Oh, I probably should have just ran that so I would know before even starting. Okay, so once I do that, I gotta call ADC, or if ADC underscore one shot channel or configure channel, and I have to pass in a handle, so the pot handle, the ADC channel, which I want ADC underscore channel, this is 3, and the channel config, which is the pot channel config, return pot underscore init fail, Okay. That's good, and then, okay. Let's see, on here, I want to read, what's half of 3.3? 1.65? Let me get it around 1.65. Okay. I have it around, so this should be half of what the thing is. So I'm gonna need some type of char UART buffer of 256. I don't think I'm gonna need more than that. Then I'm gonna do an sprintf red. I'll throw this into the UART buff. Red %d on the ADC. And a uint16t ADC val ADC underscore val, and then print f %s UART buff. Yep. And that should get it stuck in the UART main. Let's just make this 0. Let's see, does this build everything properly? I guess I should have done this at the very beginning so builds would be faster instead of doing it right when I wanted to. Okay, so it does build, and I don't think with any error. Oh, an old error. Okay, so let's build monitor flash. Do it over UART. Okay, red 0. Perfect. That's what I wanted to read. Okay. So yeah, perfect. Red 0. So now if I do pot underscore init, well, we should see stuff. Actually, it should be if pot underscore init equal pot underscore init failed. Printf error occurred error potentiometer potentiometer init failed, and then I want to get stuck in a while one loop here. And then here there should be ADC underscore get raw, and in here I pass in a channel. Maybe I make a structure list to store where the channel is so I could just pass it in. No, we'll see. And this would be ADC underscore channel 3. Yep. This should read halfway of 12 bits. So what, the 2048? Oh, and immediately crashing. This is not good. So what if I get rid of ADC underscore value to go to this and leave the 0. Comment this out. Ooh, invalid width. Okay. So then how come it gets down here? Printf here. Oh, this could be it. Yeah, oh, the debug's not gonna work anyway, so. Yeah. So, because I know printf is buffered, so it needs the percent or the new line character. So yeah, error failed. And that means it's getting stuck in here. And good thing I disabled the watchdog, because if I don't have this, then you'll see that it's gonna get stuck in the while one loop and say watchdog timer went off. I don't want to deal with the watchdog timer, especially since I'm not doing anything mission critical. So I don't need to be resetting it right now. There is a really bright white light coming off of this. Let's see, will the watchdog timer set itself off? Yup. Okay. Yep. So yeah, why is it getting mad about? Does it not have those? Check the datasheet to know. I have the datasheet open over here. So let's see. ADC. Oh yeah, this is our. Go to the ADCs. I could have sworn they were all 12 bits. I passed it for sure. Watchdog timer. IGUR. Okay, yeah, I actually can't see it now. Memory. Boot control interrupt. Assistant. They gotta have like a. Yep, on analog suit. Is this what they mean? Let's go to the 80. Yeah, I think this is. So yeah, there's two 12-bit SARs, up to 20 pads, two ADCs, and they have a single conversion mode. That's what I want. Two, I don't know, oh, digital digital ADCs. I think that's what I want, some digital ADCs. So I could use DMA. Single conversion mode. Okay, so yeah, I want the digital. So I want, yeah, ADC1, digital ADC1. The major components of SAR. So I gotta select this mux to do this stuff, right? SAR ADC. Yep, I'm using GPIO 4. Yeah. Yep, this is exactly what I want. I don't care about I care about this. The clock is much faster, the sampling rate's much faster, up to 12 bits. Perfect. DMA. Single channel. Operating depending on their own respective padding tables. Type 1 data format. 12-bit resolution at 1. Because 4-bit channel for 2 DMA, type 1 are used to store. I think I want all my data to be like type 1, because yeah, I want, so this is data channel selection, and this is if you want to go between 2-bit or 2 ADCs. And I'm gonna end up using DMA, so I'm gonna keep an eye on this later on. ADC filter, kind of just hope that does some stuff for that. So I think this is if I wanted to choose which registers I want to go to. Okay, so it says 12 bits is too much. Does this let me know ADC1? So I know this is for the actual board IO mux. So GPIO 4 can only be GPIO 4. But is that not, does this, I don't think this has ADC stuff, yeah. Yeah, okay. I think I have to configure the pin to be, but it says input invalid bit width. So then if I change this to default, let's see what this does. Cancel this. I want to do all of them. I'm pretty sure I configured this how I'm supposed to. Yeah, so you do the channel, and the handle, and the address of that. Okay. So now if I do this, I don't know if in the one-shot mode I can kind of just keep calling it, and it does some polling for it. Or do I gotta do continuous mode if I want to keep reading this pin? Okay, yeah. So now this breaks, but I kind of want to connect to it here. What's connected? How do I? So I gotta monitor it, and how do I leave the monitor? Control K. Okay, Control T then. How can I connect over here? Oh, I gotta do the actual baud rate. Okay. Yep. Now let's comment this out so I can see the debug stuff that's happening. Okay, let's see. This is where ADC conflict driver not allowed to use with legacy. Okay. So maybe I do gotta look at this problem then. Yeah. So where's the... Okay, it says please, it's deprecated. please migrate to use one shot and ADC continue it. Oh, okay. So I gotta comment that out and do ADC1 underscore, is it, where's the read? I think it was just because I was using an old function, one shot read, ADC one shot read. ADC underscore one shot read, and then what does that take in? That takes in the handle, the channel, and then where to store the data. Okay. Type def struct potential. I think I am gonna have to make this. Let's just see for now. Potentiometer handle. ADC one shot read. I have to pass in the handle, so the pot underscore handle. I gotta pass in the channel, so ADC1 channel 3, and store it in this ADC val. I wonder if this will get mad since they're different data types. Yeah, because of this. We'll see how it does with the sign extension and stuff like that. Okay. So that read max, which it should not. But why did that read? Oh, because what if I make this an int? And do the same thing. So now they're matching data types. But it's 12-bit ADC. I don't know why I can't use a uint16. Let's see, does this give me a... This should be, what, 40 or 2048 around there? No, okay, so red max. But now what if I... Oh, and I gotta do... hashtag include ESP timer? Or actually, I'm just gonna use the vtask delay. Let's see, throw these all into here. This could be out here. And then vtask delay. Let's do 1000 milliseconds by. I don't even know what it is. Oh, port tick period ms. Yep. Should be different readings. I don't know. Let's see what else I have to do. Gonna make this all under to do. What if I start changing up the ADC stuff now? Oh, okay, so that dropped for... Okay, so yeah, when I'm reading down here, okay. This is reading 0.4 volts. It's like it has an internal VREF that is getting messed up. Let's see where they define this struct. That should be here. I want to see what other clock sources there are. want to know if there's like any examples of this. Go to references, that's what I want. I want references that use this. Where, okay, yeah, that has a, ADC digital clock source. This is, I think, what I want. Okay. Because, yeah, I'm not using the RTC one. I'm using the digital one. Let's see if that changes up anything. Oh, okay, wait. No, but then this is still... As soon as I go past 1 volt, it maxes out. Okay. What's the VREF on the ADC stuff then? One shot read, okay. ADC digital pattern stuff. That's for DMA stuff. I'm not doing DMA stuff. ADC unit 1, channel 1, attenuation. The bandwidth default. Okay, I'm going disabled mode and then ADC. I'm not doing anything with DMA stuff, so I don't care about those. One shot, okay, so there's that. Handle, okay, one shot read, one shot delete unit. IO to channel. Okay, and one shot could calibrate a result. Maybe this is what I'm... Yeah, maybe I need to calibrate it. But let's ask the chat right now if I... Oh, let me actually get rid of that. Let me ask chat what's wrong with this. Because right here, and then the ADC maxes out at, I want to say like 1.1 volts. It's probably like a third of what the VREF is. Let's see, it has 2. Oh, okay, so if I want the range to go, I need a dB to 11. But then if I go here to dB, so this is, it will be attenuated. I wish it told me what the attenuation changes. It probably does somewhere, but I have no idea. So right here, the attenuation referred to the on-chip. Okay, so reference manual. Yeah, reference manual. Let's see where it talks about attenuation in here. Digital analog controllers. And then interrupt when scanning's done. Single channel. Okay, that's DMA stuff. ADC filtering. Where does it talk about the attenuation? Threshold. Okay. Yeah, I don't think this thing talks about. Okay. Yeah. Okay, maybe I just needed the attenuation. Okay, yeah, because these look like they're... So yeah, so if I'm going around 1.65, this should be half of what that... Yeah, we'll do some conversions later. Hopefully go with the ideal conversion. Hope it works. I'm going to change this to ADC val is equal to ADC val times vref or wait, no, it's, yeah, times vref divided by the pod ADC max. And this should give it to me in millivolts, because this is the ratio between that times the maximum. Okay, I should not be reading 44. Oh, because it's using 13 bits, huh? That's weird. But yeah, I was reading... I'm saying that's deprecated? Okay, this would be... this is 17... This is 1.39 volts. That's reading wrong. What happens if I max it out? 30... Yeah. Okay, so it's maxing out early. So I do gotta do some calibration stuff for it. So yeah, I want... Let's give it... I think this is what it's looking for. And it said that's deprecated, and I want change this to be 12 bits. Okay, that build, will it flash though? That's the real question. I know I haven't even got the PWM yet. I've been going for an hour already? Dang. Okay, one shot, invalid bit width. That makes no sense though. Okay, what if I change? What if I go to like 11 bits then? Or does it, can it only do 12? I'm curious. Or 13 bits, I guess. Let's see. Will it say invalid bit width? Yeah, it does. Okay, so then if I change this to 13, then... Okay. That's still high on what it should be reading. This is... Yeah, that's off. So what happens if I mess with the attenuation? And say made it like 6 then. what does the attenuation change? What does changing the attenuation do? Okay. So this is saying that should be max. Okay, because I want everything from, where's it? Okay, this is done. ADC types, that's what I care about. Where do they get the attenuation? Okay, yeah. Change that to 12, but then that just makes it unreliable. Okay, well, whatever. I have something that's kind of working how I want it to, but this is kind of more like an analog read for Arduino. So what if I'll leave it how it is for now because I'm not using it for anything more than this. So it works. Okay, yep. Reading. Calibration's off, but that's perfectly fine because we can just do that this way. Let's see. New blank sheet. ADC cow. We can do it this way. So analog value, I guess true value, or voltage. Do some linear calibration. Voltage, digital value, and then convert this to millivolts. So this should be on 0, and then everything's going to be equal to this times 1,000. 0. Okay, so at 0 volts, I want the raw reading. So we're gonna and let's get the average of this. So in ADC, so yeah, we'll do that. And we'll do int ADC vals. Let's go for 100 of them, or 1,000. No, let's go 100. 100 I feel like is a good amount. And pound define ADC buff size to be 100 of them. ADC buff size, change this. Okay. And let's do void get ADC samples. I'm just gonna call it cal because that's what I'm gonna be using it for, and then I pass it an int pointer of the buffer, int buffer size, fill buffer. Yeah, let's do it that way because that's exactly what I want to do. So right here, void fill buffer takes in an star pointer of the buffer, int of the buffer size. So for int I equals 0, can't type I equals 0, I is less than the buffer size, and then just increment I plus plus, buff I equal ADC one shot read, and then call ADC channel 3. Oh, I have to pass it into the handle. I forgot. And I want to make this buff I. And then just return. After I'm done reading all of those, ADC val, that's common. Okay, and I want to get the average, so I kind of void get, I'm just going to do this on main because I don't think I'm going to be redoing these all, so let's see, fill buffer of ADC vals, and then ADC buff size, and for in I equals 0, I is less than ADC buff size, I plus plus, uint 32t sum equal to 0, sum plus equal ADC underscore vals index at I, and then sum equal sum divided equal ADC buff size. Oh, I kind of want, okay. And then replace this with sum. Oh, okay, so I'm just gonna go with this, that, change this to ADC val. Let's see, because that should read 100, take the average of them, and what the average value is, so I can do some calibration. Okay. Let's see, and here, print as done filling up buffer. Let's make this 1,000. see. Oh, I ran out of space. Okay, then if I change this back to 100. What error was I getting from that? Okay. I'm gonna make that the okay, yeah, so let's start with 0 then. 0 volts. I'm reading an average of 7. Okay. And up to 0.23 volts, or here, 0.23. Here I'm reading a digital value of around 677. Jump it up even more. 0.263. Here I'm reading 2041. I saw that number twice. 1.07. Here I'm seeing 3324. 1.39. Here I'm seeing 4410. 1.76. And this is reading 5681. 2.19. 6928. Okay. Let me get like a 2.5 or 5.6. This is, oh, okay, this is where I'm starting to see it start to 8254. Is this maxed out? Let's see. Okay, I don't get more than. When will the numbers start to go down? I think I'm hitting the upper limits then. Okay, yeah. So this is so up until 2.5 volts, it looks like this is 2.51. This is 7979 then. And if I get some more data points around here, 2.34. This is 7451. I'll look into some outside ones. I already have one around there. Okay, 1.47. No, okay, I think I'm good enough with all of these. And then if I graph this, if I move these over here, because I think this is how I want it. And then insert a chart. And yeah, with digital values here, I'm pretty sure. Because that will tell me what to skim it down by. And then series, draw the trend line, and then use the equation. Okay, I think it is the other way around. What if I swap these? Okay, no. Insert chart. I want the trend line. I want to see what the equation is. How did I do this before? I know I did it for school. Let me just. Okay, yes, I want digital on the bottom and then millivolts on the side. Yeah. And if I multiply, oh, okay, what if I want, do I do microvolts then? Multiply this by 1,000, 1, 2, 3 million. Okay. So now if I do ADC underscore val minus is equal to ADC underscore val divided by that number. Wait, is it? Because if I do this number, ADC val divided by this, by 316, 312, then minus 8,600. No, I don't think that's right. How did I do this? It should be... Oh, okay, so I have to multiply it by that number, and this should give me millivolts. Okay. Should output microvolts. Let me see. Because, yeah, this digital number times that minus this zeroes it out. That number looks way too big, though. This should be... Yeah, and it's throwing out random stuff every single time. Oh, did it have something? Okay, what if I make this a uint 32 sum? Sum equals 0. Oh, I did forget to do that. ADC value equals sum, just so I can not be losing my mind again with these big numbers. Okay, right. And then this should be microvolts. This is 1.4. Let's see if I can match one of these. So this is 1.39. Should we read? Yeah, okay, around the same thing. Now what if I did micro percent? Yeah, I'm just gonna leave that as this, and then mess around with the sum down here. Or actually, what if I long unsigned? Alright, there should be some, and here I mess around with this, where it should be ADC value equals sum times 3112 minus 8600. And this should be ADC underscore val. No, but this I also I want them both to be uint32s, because this shouldn't ever go underneath 0. But I will leave it as an int for now. Okay. An error. Unsigned int. There's a long unsigned int, which is LU. Okay. I knew I had. Okay, let me hit the flash monitor. Huh. I didn't know. I didn't think the ADC was going to take this long. Good. Oh. This looks somewhat right. 1.36. That's closer. Okay, and then if I do this divided by, if I cast this as a float. Oh, okay, yeah, so change this to F, and then do, okay, I only want 3 of ADC underscore val divided by 1 million. I think it's a dot, that's why. Yeah, that was a dot. I knew it was one of those two. Okay, 1. Oh, okay. This is around 1.85, so we're getting closer in the calibration. 2.35. This is 2.71. And then Okay, so above 2.5 volts, it seems to. I think the sum was throwing it off. Let me try to do all this stuff again. I think I'm close to the magic numbers that I want. So yeah, this is reading like 11. This is 0.09 and 216. Point 0.27. Okay, yeah, what if I try to hit the same thing again? Oh. Yep. This is 0.27, and this is giving me out an 848. .85, or actually I want .769, and this is giving me 2190. Here we have a .98. This is giving me 3144. 1.13. We have 3632. 1.14 or 1.41. 4470. I do want more values around this range. 1.6. This is giving me a 5110. 1.86. 5857. 2.05. 2.19. I'm definitely getting more points now. 6930. 2.35. This should be 7401. 2.41. 7717. 2.51. 7948. Okay, and then right before it maxes out at 2.7 or 2.54. And then this is 8124. Now when can I get it to max out? Okay, right here, 2.57. And this is reading 8191. Now with all of this, I should hopefully have a more accurate chart. And therefore, okay, 31 times 314 minus, and I think this is only for this channel too. I think I'd have to do it for, okay. So now if I flash this, I should have accurate measurements up until 2.57. Okay, 2.56, okay. This is 2.4, 2.0, okay. 1.74, 1.4. Okay, now I'm getting fairly accurate. Yeah. Okay. Yeah. Okay, this is really accurate. Now let's throw these onto their own thing now. Of new, I do want a potentiometer dot h new potentiometer dot c. So if not define potentiometer underscore h, define this, and if my site include everything I used over here. Oh, I actually didn't use that at all. Now this should only have to include potentiometer dot h. And then I will take all of these up here because those are all part of this now. And then, okay, so define magic cow x, define magic cow y, ADC, actually let's go everything prefixed with that. This will be 314 and this will be negative 4241. And then uint 32 underscore t get potentiometer, get pot microvolts, int actually this will be 0, this will be 1, and pot underscore init. Yeah, so I'm gonna go very in detail about this. Hashtag include potentiometer dot h. I'll make this static because I only want it to be of this for this file. Okay, and then uint 16 get pot raw. Uint 16t get pot raw. return ADC underscore one shot read, pass in the handle, ADC underscore channel 3, and then static, I guess this is uint val. Throw this on side of the val. Return, oh, wrong thing. Where's the ampersand? There. Return uint 16 and then val. uint 32 get underscore pot. Raw is equal to get pot raw. Also, let's see. Define pot channel. Pot channel. Return raw times the pot underscore magic cow that minus pot magic cow y. Yep. This I might have to do some clamping so that way it doesn't go underneath and over and underflow. But for now I think we're good. Now if I do pot underscore handle, or it should be pot underscore get raw, or I think I will. Okay, so I'll do, that's what I'll follow. Get pot raw, pot underscore get raw, buff I, uint 32 under C, convert to this. Okay, and then if I do uint 32 underscore T, convert to that. I'm just gonna make this a pound define. Convert to, yeah, microvolts, taking an X that I wanted to do. X times that, and then revert, return, convert to microvolt, X. Oh, this should be raw, actually. And then so that's the fill buffer, get the average, and then ADC underscore val equal convert microvolt and the sum. Yep. Okay. So yeah, this is my initialization code and the main loop. Fill the buffer, okay. Will they all build together? I think I have to add it to, let's see, trying to figure out now how to add, and yeah, let's say it sees it. So let's get some clean messages. Let me just try to build. Okay, let's see where it's getting the error from. So undefined reference, get raw. Reference to, okay, and then okay. Tree. Tree underscore car. Oh, okay. Tree underscore under main. This is what I want. So let's see. This one I'm done with. Modify this CMake list for this directory. Let's hand in the CMake list. And it's handling, oh. No, no. I just wanted to do this. Oh. Okay, so let's see. So I think I would add that. We're gonna do anything for the .h then? Okay. And then they should just be potent geometer.c. Okay, I think, yep. Fill buffer. Undefined reference to require, okay, set, add directory for headers. I do have it in here too, that's the thing. So what if I clean everything and then try to do it? Let's see where they have full clean. Now I try to do it. Let's see. Okay, it's still not wanting to work, and I don't want. Check and look at my whole thing, right? Empowered by AI. It's in this make file. Okay, so for VS Code ESP IDF. Hopefully this knows what I'm somewhat talking about. Yeah. Do I have to do the H maybe? And then that will work? Okay. If I hit it with that. Okay. Yeah, it is in my main.c. So main.c. Yeah, that's potentiometer.c. Yeah. Hmm. How to use example folder, sample project, okay, build. Well, I go here and it has something about starting a project with more than one file. Okay, so what I've added to components, I think I do. Mandatory parts, okay, optional components, there, search default. Let's see. Preset. So here, oh, okay, so components then. So yeah, it does have components. So I have to make one up here. Components. Then here I gotta add potentiometer. And so I want to add button 2. Button. So source. Okay, so if I wanted something like this. Okay, I don't think that needs to go in there. I don't think I need this. No, yeah, what add to main then? So that requires engine. So then in main, this top one, I change this to require. All right. Yeah, potentiometer. Now, no, damn. Why not? Because that requires potentiometer, and then sources. Yep, include. Do I have them in components? Tree. Do I hit the clean right now, actually? Because I'm going to do anything with build. Clear. Hit with the tree. If I throw this into chat now. Okay, so this is what I want. The add subdirectory. Oh yeah, so change that. Hopefully. Nope. A component. Ignoring duplicate. Okay, well I can't change the. Okay. Message require not a directory. Oh, components. Okay. Components. There we go. Main requires potentiometer. Okay. I think I need to do a full clean. Close out of this. Let it all from scratch. Because as soon as I can add one thing, then adding multiple is easy. Okay, add not a directory, main. Okay, let's go ongoing. Let's see. I really have that. This is for the potentiometer, which is exactly what I have. This is the top level one. I don't need to get ignore. Cannot find the full clean. The build from nothing. Okay, target build generic. Okay, reduce a dot out. Parsed implicit. Where did it say like something broke? Wait, what? What if I leave those out? That's it. Okay, what if I change this all back to the if I just do if I just try to build this simple thing? I break it now? Okay. This is not bad. This is not bad. Okay. Why is this not working? I see, chat. Do you know? Okay, so I'm gonna change this thing to require driver, I guess. Does this include everything? So what if I add it back in here? Okay, that makes sense. What if I bring all this back? Bring this back in here. Let's see. I'm just gonna hand it all this with that file tree. Hmm. Let's see. Yeah, at least with the cube IDE, it was easy to do this. It's CMake that I have no idea what's going on. Undefined reference. I don't know why it's undefined though if I define it here. Oh, wait. No way, this is it. If this is it. It was. I am severely annoyed with myself. Let's see. Why the components? I wanted to make one for this. Do I have to add a? Oh, I do have to add one. If I give them a c make list.txt. Let's see, will this work? It's not a directory. Okay. Okay, so it says check the CMake log. That means it doesn't even make it this far down. I want to have everything in the top level. Yeah, that's the, this should piss me off. Why is it saying file? This isn't gonna find the file specify. Okay, I think this required. Alright, everything goes in the top level then. That's Mission U1C me. Okay, build. What happens if I go to flash at all? Because I think this is just what it's going to be like. Okay. Alright. Good enough for me. So clear, get status, get add rccard.ecu, cmake, rccard name, get status, get add, or get commit, dash n, potentiometer, driver, done, I guess. Get push. There we go. That's a lot. That took a long time just to do potentiometer stuff. But